Alright, today we're going to be going over graphing rational functions and specifically going over the domain and range for the expression. So you're going to need a graphing calculator and a piece of paper if you want, and we're just going to run through some problems, kind of learn how to do these. So first, whenever you're looking at it, you have to graph them from an equation. So, for example, number 1, I have f of x equals 1 over x plus 2 plus 4. And it might be a little confusing at first. So if this was a graph, what you're going to have is the x plus 2. That's going to really mean kind of minus 2. So if there was like 2 units this way, that's where you'd go. And then the plus 4 at the end, it actually means plus 4, so you're going to go up 4. So 1, 2, 3, 4, and then you'll be somewhere up here. Now from there, you're going to pretend that this is a point, and you have what are called asymptotes, and they're just this kind of imaginary dotted line that run from -2 and +4, as if it was a unit. And then the actual expression, what it's going to look like when it's graphed, and I'll show you in a second. It's going to look something like this, kind of this curved little line looking deal, and it's never going to touch the asymptotes, these invisible lines. It's never actually going to touch them, but it'll just keep getting closer as it goes on forever. So just kind of what it looks like. So get out your calculators, and you can graph this, or y equals 1 over x plus 2 plus 4, and then we graph that. And so, as you can see, it looks something like this, and that's what it's going to look like. It goes on forever. And so, the domain and range, as far as that goes, is going to be, or the domain is how far it goes, left to right, like along the x-axis. So, and then the y is how far it goes from the bottom to the top along the y-axis. So, like for this example, it goes from -infinity to -2, and then since there's a break here, because remember it's never gonna touch that line. There's a break, and then you're gonna have a u. My bad. You're gonna have a u here to show that there's a break, and then you're gonna go from -2 to +infinity. And that's how to graph the domain. And then the range is going to be from bottom to top, so it's going to go from -infinity again to 4. Again, you have that break with the u, and then from 4 to infinity. Right. So you can pause this, rewind this if you need, but that's kind of what they're all going to look like. Alright, so let's go try number 2. So if this was a graph, since we have a -5 and really means that +5, it's going to be 5 units this way. So 1, 2, 3, 4, 5. Pretend there's something there. And then the +2 is just +2. So 1, 2. It's going to be somewhere over here. Draw your invisible line, the asymptote. Same thing as last time, kind of. Just practice. And then you're going to have the actual expression looking something like this. So, there you go. And so the domain and range for that, you're going to have, again, starting with -infinity. And then this time we're going to 5. Then you have that u. And then you go from 5 to infinity. And then for the range, you have, again, -infinity to 2, and then a u, and then 2 to infinity. And as you do more of these, you'll get more used to it. You'll see the patterns. So you don't even really have to graph it after a while, because you can tell from the equation that the domain and range are going to be, the -5, so it's going to be +5 and then 5 to infinity, and the same thing with the 2 to get the range. And that just comes with practice. You'll get better and better at that. You have some more to try, and some of them will get more tricky as we go. Alright, so this next one is pretty simple. X equals 1 over x plus 3, or y equals 1 over x plus 3 minus 5. So the plus 3 really means minus 3. It's going to go over here, and then -5 actually means -5. 1, 2, 3, 4, 5. It's going to be somewhere down here. Draw your invisible asymptote as if this circle was a point, and then the domain and range will be negative, well, actually draw it out first. It'll be -infinity to -3 u -3 to infinity, and then the range is going to be -infinity to -5 u -5 to infinity. Alright, so now we're going to get into some different looking equations. Let me just switch this out. So this one's a little bit tricky because you'll notice right here, instead of in the past where we had just a 1, this is now a -1. And all that's going to do is, whenever, the expressions, they look like this, okay, instead of that, they're going to be the opposite. So they're going to start looking like this whenever they're negative. And that's the only difference. Everything else will stay the same. So we'll run through a few of these. Alright, so the first one, so we got +3, which really means -3. 1, 2, 3. And then +2. So 1, 2. So if you got there, draw your invisible asymptotes. Alright, and then instead of it being like that, it's going to be like this. And that's the only difference with that. So, I mean, it's a little tricky. You have to watch out for those, but it's not really that bad. You can definitely tell. And so the domain and range will still be the same as you did in the past. So -infinity to -3 u -3 to infinity. And then the range will be -infinity to 2 u to infinity. Alright, sweet. So I hope that wasn't too complicated. Hope y'all are still with me. Alright, so this next one is going to be pretty similar. The only difference is you'll notice there isn't this little, like where there's a +2, we don't have that. And so that just means you'll only move along the x-axis and you won't need to move up. It's as if there was a +0. It doesn't affect it. It doesn't matter. So if we draw this this thing, so it's still a negative like the last one. And so the -6 really means +6. So 1, 2, 3, 4, 5, 6 over here. And then since there's no other thing to do, that's where it is. So you draw the invisible asymptotes. And of course this asymptote's actually going to be on the x-axis at 0. And then since it's a negative, equation will look like that. Your domain and range be -infinity to 6 u 6 to infinity, and then your range is -infinity to 0, because it's on the x-axis, u 0 to infinity. And when you're writing these, since these things are never going to touch the asymptotes on either way, you're always going to have an open parenthesis. You're never going to have a bracket, because the bracket means that it's touching the line, and it's not touching the line ever. So it's always going to be, an open circle kind of deal where you'll have the thing. So don't get confused on that. All right, and then our last one we have here. We have again -1 and x minus 9, which means plus 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then we have -3, which means -3, 2, 3. Match that up. Invisible asymptote line. You see that? And then since it's a -1, it's going to look like that. And then domain and range is -infinity to 9 u 9 to infinity, and then the range will be -infinity to -3 u -3 to infinity. So you can just practice things like these. They're pretty simple once you get a hang of it. They're all very similar. It's kind of the same deal. The only thing I would say is look out for the negatives up here that sometimes can trick you, and just know that these are never going to touch the asymptote. Even though, as they go to infinity, they will never touch it. They'll just